Good morning, everyone, and welcome to the 6th live roundtable hosted as part of the European research project Land Support. My name is Gloria De Pauli, and I'm hosting today's talk on behalf of the project partner Acteon. Thanks for joining us. Today's live roundtable discussion will focus on how forest modeling can address today's forest management challenges, looking in particular at some of the existing models at different geographical scales and at future prospects for modeling. Our speakers will, of course, tell us more, so let me just introduce them. Joining us today, we have Gina Marano, PhD researcher at ETH Zurich, Aleksandar Dujakovic, research assistant at BOKU, and Jernej Jevšenak from the Slovenian Forestry Institute. Thank you all very much for joining us today. And just a note to our audience, if you have any questions, you can put them into the chat box next to the live stream, specifying who the question is for, if possible, and we will come to them at the end of the session. So let's start with Gina. Before we plunge into some of the existing forest models, could you give us an overview of the challenges currently faced by the forestry sector and what forest models can offer in response to such challenges?
Well, sure. Let me try to share with my screen, and I would like to cover this really complex question at the end that you asked me with quite a provocation. So why do we even have to bother about these problems and trying addressing them with systems like decision support systems and even more complex platforms? Well, let's say that we are well aware of what forests are. What we are lesser aware is that there is quite a huge amount of expectation towards the role that they should have in terms of sustainable development goals. So we know that they are the very heart of the 2030 agenda, and they are globally recognized as very diverse ecosystems, but the world diversity is a nice synonym to complexity. And this much means that when complexity kicks in, we ask ourselves, which type of forests are there? What can we do with these types of forests? Where are they located? And what if we have different objectives and they can be often very conflicting? So we are very much aware and sensitive towards the definition of ecosystem services, but forests have their functioning on their own, and they are on the planet well before we have been on the planet. Of course, we are interested more in concepts like optimization, but we need to be aware that forests have their own dynamics, and that, of course, climate change and the associated disturbances kick in, and they can be quite of a challenge and of a problem. And whatever we want to do in terms of optimization or prioritization of ecosystem services, we need to address a specific spatial scale and temporal scale as well. So all in all, as the Global Forest Resource Assessment has taught us, the objectives can be very conflicting. We see in Europe that we mostly prioritize over forest production, and therefore we want to manage quite a lot. So circa 96% of the proportional forest area in Europe is covered by forest management plans, but who is managing? Often the public sector in Europe, for instance, is the main actor. And therefore, decision makers and forest practitioners have to take active decisions, and they have to face a large climate of uncertainty. I mean, this publication of Seidel et al. Is quite of a benchmark in terms of making a global assessment of what the future challenges might be in over a scenario of warmer and drier climate or warmer and wetter climate, but the result is the same. We need to be aware that we are going to face a bunch of challenges also due to disturbances all over the globe, not just in Europe. And what to do with this bunch of issues that we have to face? I mean, we mentioned that we could have multiple objectives. We need a lot of data to assess over different opportunities. And we might have questions like, what happens if I change this? What happens if I want to prioritize over one objective or another one? And often decision makers and also forest practitioners would like to rely on softwares that are open source or systems that are friendly in terms of a graphical user interface, and hopefully they could also be addressing problems at different spatial scales and temporal scales, as we said. So if we want to take some decisions, we need to make some thinking. And often the person that I highlighted in here in green is a person like a researcher, like those nice people that we have in here today, and those that are listening to us, that are a sort of what I define the forest heroes, because they have to bring together models and methods, and they need to make these model outputs available for many people that just like to navigate through a graphical user interface and benefit from this huge amount of knowledge. And all in all, what decision support systems are, even if this image is quite nasty to see, it's quite simple. I mean, they often have their systems, they are informatic systems, often structured in three-tier cyber infrastructure. They have some databases, they have really powerful servers to do some computations and some modeling application. And then through a graphical user interface, we can fully benefit from these systems. And there are really many systems out there. In a paper of 2019, we reviewed over 60 onces, but in the meantime, the world goes ahead. And for those that are interested, they can navigate through nice platforms like the Forest DSS Community of Practice, and they can just choose what they like. What we must be aware is that, of course, since the challenges are many, and we are like, oh, of course, we're humans, we like complexity, we need to make sure that whatever system we choose, we don't go into too much complexity, because sometimes this brings in many errors, a lot of resources, both in terms of economics and in terms of capabilities, in terms of computation, I mean. But yeah, we need to keep ourselves simple. And hopefully today we're going to listen to some of these applications that are quite consistent in terms of simplicity, and at the same time, they provide really interesting outputs. So this was my quick overview.
Thank you, Gina. It was very clear. In the context of the Land Support project, the Slovenian Forestry Institute is currently working on the MLSF model, which will be then integrated in the platform. Jernej, can you give us an overview of the model you are developing?
Thank you, Gloria. Of course. Yes, so as Gloria said, we are currently developing a completely new model at Slovenian Forestry Institute, which is called Machine Learning Forest Simulator. So this is actually the first of its kind, the model that will simulate forest growth, and it will be based completely on machine learning algorithms. So what does it mean? So one of the, I would say, most important problems in forest modeling of existing forest models is the need for parameterization. But on the other hand, machine learning is based on the principle of learning from data, which means that all the parameters which are needed for the simulation in the future can be learned from the data. So this is completely new forest development model. We are now working on it for about 2 years, and we already have the first version, which is available as R package, currently on GitHub, but we are planning to also post it on CRAN. So when we develop this model, we have in mind that it should be as general as possible, so that we can make it very user-friendly and useful for different countries and for different data structures. What is important is that it is based on inventory data, so forest inventory data, which is sampled across the globe. And then users have many different options from selecting of machine learning algorithms to selecting the forest processes to be simulated. But in general, it simulates all four forest processes, which are the most important, starting with mortality, radial and height growth, regeneration, and the ingrowth. And of course, one of the most important factor which affects forests is also human. So harvesting is also included, and this is very sophisticated part of the model. So there are many different ways how to specify harvesting in this model. So I would now like to give you just some very brief results, very brief preliminary simulations for Slovenia. Basically, we have selected two RCP scenarios. So let's say RCP 4.5, which is more realistic, and one a little bit more pessimistic, RCP 8.5, and different harvesting scenarios. So depending on forest yield to be cut, we selected 50%, 70%, and 80% of harvesting. So those are really some basic plots. We are preparing some publications related to this, but as we can see, with the model, we can study the effect of harvesting on standing volume, the effect on harvesting on forest yield, also on mortality, and also on the ingrowth. And so those preliminary results show that the outputs are realistic and expected. So if we harvest more, then our standing volume is, of course, it increases less. And if we harvest more, our forest yield might also decrease. So those are all parameters which can be addressed in our studies. The model is currently, I would say, ready for use. It can be downloaded from GitHub, as I said. We consider the preliminary results to be very promising. The model can be used on different scales, from local to regional to national. It only desires that users have enough data. So this is most important, and the data comes from at least 2 inventory periods, because we need somehow to show how trees change in time. So currently it is based on so-called concentric plots. So this is special design of forest inventory, which is very common in Europe. But in the future, we will also adjust the model for different kinds of sampling plots. We plan to move to improve some of submodels, because currently we realize that to estimate and to model mortality, it's really difficult. So we would like to improve this part. And we are also currently running some tests on ICP forest data. And I hope that next time I will also be able to share with you these results. So if you will have any question about the model, I am happy to answer you. And I definitely look for a discussion, and I hope that it will be very useful. Thank you.
Thank you. But so how will the model be integrated in the Lens Support platform, and will it be possible to upscale the model to other countries?
Yes, absolutely. So as I mentioned, the model is based on existing data, and it can be run only if data is available. So we have decided that for the Lens Support platform, we are going to simulate a number of scenarios for Slovenia, from different harvesting scenarios, mortality scenarios, climate scenarios. And then the users on the platform will be able to choose a specific parameter and to see the outputs of the most important forest attributes, as standing volume, mortality, harvesting, forest yield, and so on. So this is going to be implemented on the Lens Support. And yes, as I mentioned, the model is designed and developed for many countries. So we try to make it as flexible as possible, and it can be upscaled to any country which has sufficient data.
Thank you. And moving to BOKU Vienna, is a partner in land support, which is working mainly on satellite and remote sensing data. In parallel, however, they are now starting a feasibility study on how to move forward in forest modeling. So, Aleksandar, can you tell us more about your work?
Thank you, Gloria. Yes, we at BOKU, at the Institute of Geomatics, we are dealing with satellite data, remote sensing data for forestry, agriculture, and other fields. And the topic of this project of our work is quantifying net primary production of carbon for forest ecosystems. So net primary production is basically the difference between accumulated carbon through photosynthesis and carbon lost through respiration. It is important to quantify net primary production of carbon to assess the impact of climate change on forest ecosystems, and also to estimate the potential supply of biomass in forest ecosystems. There are different methods of carbon estimation and net primary production estimation. First of all, we have forest inventory data. In this case, we have a timber volume increment, and it is converted with biomass expansion factors to biomass, and then from biomass to carbon accumulation. But we are focusing on satellite-based models. So with satellites, we can cover entire globe pretty quick, and it is convenient. And the highlight of our model is MOD 17 NPP model, so net primary production model from MODIS, which has been around for the last 20 years or so. It has been used widely, and it has spatial resolution of 500 meters. So our goal is to increase the spatial resolution with the emergence of satellites like Sentinel-2 and other data sets which have high spatial resolution. We are implementing those inputs in order to get spatial resolution of 10 to 30 meters for net primary production. We are doing that to be able to measure net primary production for forest stands, forest compartments, some small forest plots, which are smaller than average MODIS pixel. Gloria?
And how do you imagine the results of your study being used in the future?
So provided that this model is accurate enough, it could be useful for forest managers, forest owners, policymakers. For forest managers, it is important to in a way estimate the impact of forest management practices and the different harvesting systems on the net primary production. Also, with high spatial resolution, we can see the difference between different forest stands, forest regions, or between private-owned forests and state-owned forests in terms of accumulation of carbon, net primary production of carbon. So it could be also useful for policymakers, decision makers. And it is important to mention that for model calibration and estimating model performance, it is important to compare the modeled NPP, net primary productivity, with NPP obtained from forest inventory data. And the thing is that forest inventories are usually done on a plot level or on a stand level, which is a lot smaller than average spatial resolution from MODIS. So we need to have high spatial resolution so that we can compare two results of NPP from two methodologies on the same area with the same shape, same size, and same resolution. So I will now show you basically a presentation of a roadmap for implementing high spatial resolution method and to show you the final product. So I have some problems with. Yeah.
We can see.
So MOD 17 model is basically a light use efficiency model. We have absorbed solar energy, which is then converted with a conversion efficiency factor, satellite data, climate data into the final net primary productivity. We have three groups of inputs, so satellite data, climate data, and biophysical properties of land cover type, which is biome-specific values based on land cover classification. This is the algorithm of the model, which consists of two parts. First is calculating gross primary production on a daily level. Second is the calculation of respiration loss. And in the end, we have a gross primary production minus respiration, and we get annual net primary production. For first group of data set, we use satellite data. So LAI, FPAR, land cover classification map are all obtained from a satellite data set. Then we have a climate data set for short wave radiation, vapor pressure deficit, minimum temperature, average daily temperature. And we use those data to attenuate biome-specific parameters and the maximum light use efficiency, for example. And then we have biome-specific parameters. They are all based on land cover classification. So each land cover class has a specific set of parameters for each biome. Like I said, Mod 17 NPP model has spatial resolution of 500 meters. So inputs like land cover, LAI, FPAR have the same spatial resolution. Climate data set is using a 0.76 degrees resolution, which is then spatially interpolated for each pixel. The idea is to replace all the inputs and then to rerun the same model in order to get final 10-meter spatial resolution net primary productivity. So for land cover, we are using 10-meter resolution product from Sentinel-2, so for land cover classification net. Then for climate, we are using a European climate data set, which has resolution of 0.1 degrees. And LAI, FPAR are estimated from NDVI, which is obtained from a harmonized Landsat Sentinel dataset. A harmonized Landsat Sentinel dataset is a product from Sentinel and Landsat. It has a high temporal resolution, 2 to 3 days, and high spatial resolution, 30 meters. So with all those new inputs, we are able to get a final product, which is a raster with 10-meter spatial resolution on annual basis. This is one example of final product. So we have a raster with a pixel size of 10 meters, where each pixel represents accumulated carbon in kilograms per year per square meter. For example, if we have a shapefile of forest stands or forest compartments, we can extract the net primary productivity values for each stand separately, even though those stands are small or irregularly shaped, which is usually the case. And also we can see the difference between net primary productivity between different stands. So borders are taken into account, stand borders. This is another example. Since we are using a land cover classification map with a 10-meter resolution, so those small pixels are able to detect small changes in forest areas. For example, if we had some disturbances, clear cut or forest fires, so those pixels are basically not classified as forest, and therefore their NPP is not taken into account for final calculation. And we can also see that for forest stands, net primary productivity is pretty uniform for forest stands individually, which is expected. For testing, I will show you the preliminary results and first results of our testing. We compared the two models. So modeled MPP with 10-meter spatial resolution and modeled MPP with 500-meter spatial resolution. And we tested that for areas in Slovenia, for plots from National Forest Inventory. And for this area, we got on average 12% lower results with the increase in spatial resolution. So we got for each year for which we did the testing, we got lower results. So we can say that with the increase in spatial resolution, NPP is decreasing for this area. So next step would be to compare these two modeled NPPs with field NPP. So net primary productivity obtained from forest inventory data, and then we would see what is exact precision of increased spatial resolution. We can sum up that with this model, with higher resolution inputs, we can take into account spatial heterogeneity in forest ecosystems. We can extract net primary productivity of carbon for forest stands, forest plots, so for small areas. There is a high availability of high spatial resolution data, which can be easily used and implemented. And for evaluating model performance, like I said, it is better, and it is better to compare high spatial resolution model with, so to say, a real MPP. So MPP obtained from inventory data with bottom-up approach. What we also did is we analyzed the correlation between annual net primary productivity and periodic annual increment of timber volume for these plots in Slovenia. So these plots from National Forest Inventory in Slovenia had size of 500 square meters. And for these plots, we didn't get the correlation between annual NPP and increment and timber volume. So one of the reasons for this is that biome-specific parameters are calibrated to global conditions. And they cannot good enough represent small changes on small area over a short time period. So the next step would be to upscale our testing area. So to test modeled MPP and increment data and inventory data on a stand level. And most importantly, we need to compare modeled MPP with net primary productivity obtained from inventory data. And then we would know for certain what is the average error of model for forest stands. And one of the possible improvements would be to calibrate the model parameters so that they match local conditions in Slovenia or in Austria, where we are also doing our testing. So that is the plan for the further work. And thank you for your attention. I will stop here.
Thank you, Aleksandar. So far, we looked at a model at the national scale and at the prospects for future forest modeling. Now we get our feedback to the ground to the land support forest subtool, developed for the local scale and specifically designed to serve daily activities of local authorities in charge of forest planning in the Campania region. Gina, you developed that tool. Can you tell us more about it?
Yeah, sure. With pleasure. I again have to be tedious and share my screen, but I promise I won't take too long. So the main challenge for land support, of course, was to deal with the forestry sector, and for a region like Campania region, where I come from, let's say that the forestry sector is a quite promising branch of the economics, I would say. Sure, our main challenge was to sort of decline and apply the European forest strategy at a more operational level. So matching the real needs of the forest practitioners on the ground, as you said. And of course, to try to integrate also soil information and forest information as well. And I will explain this in a minute why this was particularly relevant for our case. So the methods that we chose to proceed in this challenge was, of course, to involve stakeholders, because we had no other way how to design or even think about the different possibilities, which problems are there on the ground, which problems are the forest practitioners facing. And of course, we had to put our hands on the data. And this was quite of a challenge in itself, and to start designing appropriate tools for that. I'd say that we got much inspired by the SoilCons Web. This was a previous geospatial decision support system developed by the University of Naples. They are quite avant-garde in this field. And they, of course, continued and mutuated the cyber infrastructure into a new project that is the Land Support Project, which gave us the possibility to put our hands on the work and try to develop something concrete for the forest practitioners in Campania region. We use this region of interest concept a lot in the land support project. In this case, I used it for really spending 2 words of the Campania region, so the real region in terms of nuts level understanding, so to speak. So why Campania region? Because many people might think, especially in Italy, like, okay, there are not so many forests out there, but instead the nearly 33% of the territory, I know that these are quite old data, but the 2015 inventory data have been released some weeks ago. This should be a bit updated, so the number might be a bit higher. But roughly 34% of the territory is covered by forests in Campania region. And which kind of forests? Well, mainly broadleaf forests. We have quite some beech and some oaks out there, and of course chestnut production is relevant. And you know, when there is something relevant, management kicks in, because of course forest practitioners have quite overwork, and especially they have to face quite some problems, so to speak. We started our hunting and the designing of the tool and the framing of the problem, of course, beginning from the issues, meaning that we had to, we spoke to the decision makers, so to the main forestry office of the Campania region, and we got to know that basically there was no informatic database on forest management plans. A lot of technical knowledge got lost somehow because there was not even a forest characterization, so forest typology map available for the forest practitioners. And as I said, most of the work was on papers. So shape files were missing associated with the forest management plan it was quite of a challenge. Therefore, when a forest practitioner would need to submit his or her own management planning to the competent office, generally he or she would do it on paper, as I said, and often the paperwork is so heavy that many people will feel discouraged, and therefore there were not so many forest management plans updated out there. And often many areas would lack of any management interest, even though there is some like potentiality there in terms of, as we mentioned before, many objectives that can be achieved and forest functioning that can be maintained in the region. Therefore, our idea was to start like taking all these paper data in, digitalize them, reorganize them, so structure a database and share them with the competent authority and the forest practitioners. And hopefully this would bring in already some interest, because foresters would have felt pushed to interrogate and to use a decision support system to help them in the first stages of their planning process. And as said, why is management needed in Campania region? Because Campania region is quite problematic. We mentioned before climate change, we mentioned before the human impact and other related disturbances. And this is particularly true in Campania region due to the fact that land use change and in particular soil sealing is a huge issue in the region, followed by wildfire causes, which are mostly anthropogenic, unfortunately. And all in all, most important, and in here the soil information kicks in very heavily, and importantly, this whole territory is very fragile in terms of geomorphology, but in terms of soil typology in essence. So the group of Naples, Professor Terribile and all the others, they did a marvelous job in characterizing soil types all over the Campania region, and to scream at loud voice that decision support systems are needed, starting from the soil as first site condition, of course. Then we took some steps forward because we identified the stakeholders, who were they even there, and we designed some ad hoc questionnaires for them. What would they have needed? Which kind of data? Which kind of information was available? And so far and so forth. We did a little bit of demo with a first simple tool. We designed a more complex tool, so we reconstructed a new tool backbone, and we put our heads on the production phase. So the IT collaboration with Arespace was fundamental in here. We have tested the tool, fixed some issues, and then it hopefully and finally went into real production. And where can you find the tool? You can of course check it through on the Lens Support like platform, so the geospatial platform, and you can through the wizard menu select if you want to explore some basic features, basic data of the forest characteristics at the regional level. And when I mean region, I mean Campania region specifically. And of course, you have you are fully supported to use the tool with a well-structured documentation, because University of Naples took care of preparing really nice technical sheets for this. So this documentation can guide the user, so the forest practitioners, step by step in selecting a forest parcel or an area of interest, and then retrieving some informations that are necessary, as I said, for the first stages of the forest management planning. So all the data that we collected converged into different MySQL databases. And what are these data that the foresters can get? Of course, they can, once they have designed their area of interest and they save it, they can get information on the yield tables available at that very municipality. And then they can get informations if there are forest management plans already available, on which surface, how many are there, which are the functions of the forest that have been managed in that very area of interest. And they also get provided with a lot of information related to soil types, which are necessary to, for example, plan forest management interventions on fragile areas, and many other features. So the graphical user interface is really nice and user-friendly, so to speak. And once that the user has drawn his or her own area of interest, selected a tool on the right menu, then they can download, of course, they can first of all visualize what they have done, and on the left panel, but they can also download this data in an Excel sheet form, shapefile form, raster form, and so far and so forth. So they are fully supported, and there is an amazing team of people behind all this huge amount of work that is continuously maintaining the platform. I would like really to thank all the people that seamlessly and continuously worked on this platform, are still working on this platform and believe in this project. And of course, I'm no longer in tenure for the maintenance of the forestry tool, but I'm more than happy to answer any question. And if I cannot be physically there to answer quickly, I can redirect you to the people that can do that on my behalf.
Thank you, Gina. That was very interesting indeed. And while developing the tool, did you have the chance to work in close contact with local authorities in Campania?
Yeah, that was quite the fun part. Was to interact, of course, with the common, the main authority that is in charge for forest planning in Campania region. There is one only man, and he's a hero. Dr. Alberto Mattia, if he's listening to me, I want to thank him once more, because I've stepped into his office many times, and he was, his desk was loaded with management plans in paper form that he had to revise in really quick time. Then he was also conducting work in the field, so he had to check materially in the forest parcels if the things that have been declared on the management plans were real or not, and often they were not. So he had to take care of a lot of control work and then revision work. And of course, he was really happy to know that such systems exist, and that he would be also supported in redirecting the people, so the forest practitioners, in using such kind of technologies for their work.
And we have a question for you from our audience. And in recent years, in Campania, as in Italy, forest areas have increased. how can the Lens Support tool help to understand the dynamics and scenarios of these changes that do not seem to stop?
Well, the platform, of course, as you see in its current stage, is in the early stages of its development, I would say, because what you can see right now, for instance, for Campania region, you can check land use changes using the platform, of course. Can you check, for instance, if there have been disturbances in the forest areas? This cannot yet be done, but with change detection matrices using remote sensing techniques, this can be absolutely done. It is just needed that there is first an interesting partnership and one person that can process this data and put them in the platform. So in this, so to partially try to answer this question, the platform is there, and the will to explore and to implement new feature is there, and this can be absolutely done. It can also be done by, for example, implementing dynamic forest models over the platform. In the current stage, we haven't like published this outputs yet. Sorry, but we have used another process-based model, the 3D CMCC FEM, developed by Colalti et al. At the National Research Council of Italy, and this model allowed us for selected areas to inquire about the changes in forest productivity, as something similar to what Jernej has shown under climate change scenarios and under different soil conditions, so soil moisture, for instance. And we could appreciate how the productivity of the forest was increasing or decreasing. There are a bunch and a large amount of dynamic forest models out there that are just waiting for such a platform to bring them in and to implement them. Standscape model, landscape scale models, many different possibilities. So to answer the question, in the current stage, the platform is of course useful to detect, for example, land use changes, soil sealing, and some also other issues like potential contaminations, forest area expansion, forest dynamics. It's still in the early stages, so it's just waiting for someone to bring some data in. But the engines are there, the infrastructure is there.
Thank you, Gina, and thanks for the question. I'd like to close the session by taking a final tour de table, giving each of our speakers a chance to very quickly share or summarize what their hopes are for the future of forest modeling. And I'd maybe start with Jernej.
Well, I think that so the most important is that forest modeling actually gets maybe a little bit more attention. Also, it could be more supported by funding agencies, and I think there is a lot to do, and that forest modeling has actually only started, because the potential of what could we describe with forest models is really big, and I really see bright future of forest modeling in next 10, 20, 30 years. So definitely, I'm very optimistic about this.
Hey, Aleksandar, what are your thoughts?
I think especially regarding remote sensing and satellite data, it has really a great potential. It also has been used widely for the last few decades, and with the increase in computing power and also in spatial resolution, which we are also doing, there is a great future. And also it is important to test the models, to calibrate the model performances, and with the combination of remote sensing data and also field data, it is possible to more improve these satellite-based models.
And Gina, the floor is yours.
It's a quite difficult question for me. Now I am on the other side, so I'm modeling and I am doing a bit of forest modeling myself, thanks to the group of the ETH people. And I must say, please share your data. This is the first. I mean, it's so trivial, but it's so true. Please, people, share your data, because sometimes, I mean, you have amazing people doing great stuff. We have an example here with Jernej and Aleksandar. They're making huge work and great work, and there is a lot of nowadays of like possibilities. We have a lot of computational power, great computers, great knowledge, and then we miss the data. And or when they are there, they're not updated and they are not shared. You have to lose days, if not weeks or months, in requesting some data because the inventory data are not accessible. Then maybe you need a shorter temporal resolution, and then you have to, I don't know, invent yourself something to apply these models, calibrate these models, validate these models. So please, people, think that for everything you need, there is a modeler out there in front of his own computer, spending nights and not knowing where to get this data. So please share your data.
And take care of your modelers out there. A final and very big thank you to all of our speakers and to our audience as well. Thanks for watching us online. And we'll keep you updated for the next episodes of the Land Support Live Roundtable, and have a good day. Bye.